The video that you were supposed to watch last night is called Nomenclature. And I asked you at the end of nomenclature, extra points, if you could tell me what nomenclature means.
You asked it?
It's on your packet? In your packets out here?
It's in the tray. Well, it's not in the tray.
Oh, I asked it on the chapter 3 video?
Yeah.
At the end of, okay, that's fair enough. Keaton.
The process of choosing names for scientific
Yeah, that's right. Gnome is Latin. ¿Cómo se dice en español? Name. Nombre. Oh, gnome. Latin. Latin group. I love that. That was awesome. I was able to do that on that video. Yeah, you were with me on that one. Point. Gnome. Yeah, it means name. Clature. Clature is Latin for system. So nomenclature is a naming system. Now, in biology, didn't you hear something like binomial nomenclature? That's a two-name naming system.
What?
Binomial nomenclature. Bi, two, name, nomenclature, naming system.
So is it like, do they have their species name and their
Yeah,
genus?
yeah, genus and species, two-name
Actually got
naming
that
system.
right.
Yeah, two-name naming system, binomial nomenclature. We're just doing scientific nomenclature. This chapter could have also been called Learning to Speak Chemistrian. Okay, this chapter could be called Chemistrian. This is where the heart of the language of this class comes in. Now, you will be able to leave my class and pick up a tube of toothpaste and recognize more than 50% of the words in the ingredients. You will be able to pick up the most items and recognize at least half the names in the ingredients after my class, because I'm going to teach you how to speak Chemistrian. However, the other 50% belongs to a class of chemicals called organic chemistry, which you won't take at all in high school ever. I'll touch on it here and there, but no. That's a whole, because everything I teach you about chemistry does not apply to organic. There's two types of chemistry, well, there's three, but there's two basics, inorganic and organic. I teach inorganic.
What's the difference?
Inorganic is the chemistry of life, organic chemistry is the chemistry of life. It deals mostly with just the nonmetals, and it deals with all of the compounds that put the human body together: carbohydrates, proteins, fats, and lipids. And the rules for organic chemistry are not the same for inorganic. So if you ace your first year of chemistry in college, which is what I'm trying to help you do, when you go to organic chemistry, you pretty much have to forget everything you know and start over. Which is why organic tends to be very difficult for students, because it's a completely different thing. A lot of the rules don't apply. It's just different. Okay? You play this. My favorite game in organic chemistry is called Chasing the Electrons. True story. Well, yes, sir.
What's their chemistry?
Metallic metals, alloys. You can get a major in metallurgy.
Metallurgy?
Mhm.
Sounds like clergy. but
It does.
metallurgy.
It does. Metallurgy. Yeah. Any other questions? Any other? What? Yeah. Metals do funny things. They're funny. Anything else? Yes. Sir.
What exactly was that game that you said?
What?
Electron?
Oh, chasing electrons. Where did I made it up as I was studying. Okay, moving on. So here we go. Half of your chemistry that exists is going to be dealt with inorganic chemistry. Inorganic metals hooking up with nonmetals. I'm going to give you a little bit.
Sorry, you're trying really hard. I'm really sorry.
I am going to give you a little bit of organic chemistry, but like I said, not a lot. Mostly this. Okay, so here we go. Name the following binary compounds.
Is this lecture problem?
It is, ma'am. Good question. 1 point for you. I love good questions. Questions are my heroes. Who's feeling brave? Yes, Keaton. Yes, sir. If you spelled fluoride correct, give yourself a point. What is the first question you want to ask yourself when naming? First question. Yes,
Is it a cation or anion?
almost. Not quite. Yes, ma'am.
Will any of the symbols?
You're the closest answer I've had so far. There's one before that. I would call that the second question. Yes,
Which element
that's a good guess. Your second question is good and probably what I was saying in the beginning. My question is that a metal? That should be your first question every time. Is the first thing you run into walking down the street, walking down and go, hey, look at you, should be, are you a metal? Now, everything that was in last night's video was a metal. So then we got to Sammy's brilliant question, which should always be your second question. Sammy, what is it?
is it type 1 or type 2?
Type 1 or type 2? Good. What's the difference between a type 1 and a type 2 metal, please? Yes, ma'am.
Type 1 is a cation, type 2 is an anion.
No, ma'am. Type 1 and 2 are both metals. Please note. The diagram comes off the metal. Comes off the, even better, cation. Cool.
Type 1s have like a set charge. Type 2
Ooh.
are the transitional.
Good. Type 1, set charge. I like the word set. That's really nice. Set charge. Type 2, you have to find charge. That's the difference. So you're walking along to name the compound. You go, oh, look, it's yes, that's a cation, right? It's a metal. Okay, then our next question is, Sammy? Type 1 or type 2? Cesium is type 1 because... Yes, sir.
It's in the alkali metal.
Yes, it's in the alkali metals, which is always +1. Woo! Moving on, and then the anion's easy. Just change the ending to "-ide".
Every time you say because like that, all you think of is monsters.
3 points, that's where I got it. All right, here we go. Name it. Did I make it big enough, Lydia?
Yeah, I just
No, but I was trying. That was my goal. Make it big enough to see. Come on, somebody. Somebody. Sierra.
aluminum chloride.
Yes, it is.
Does the subscript like change the name at all?
Not at all. None, nada, ninka, do, no. Remember, the charges have to add to 0. Think of the charges as being, when a house is built, they build all of the studs for the rooms, right? The framework. But then they put up drywall or whatever, and it hides the framework. The charges are the framework for the compound. We know they're there. They're behind the wall. They give it this structure, but we don't see the charges. Yes, ma'am.
What happened if there's like a big note before?
That would just mean I have multiple of those molecules and it doesn't matter. For the naming, nothing. Good question. 3 points. Go. Yes, sir. Okay. You like the framework analogy? I just came up with that recently. Keaton. Magnesium iodide. Magnesium iodide. How many of you have made flashcards for those polyatomics? You're working on it? If you're working on it, give yourself 5. If you're not, you should be. Next. You ready? Yep. Yes, ma'am.
For like BNC, do you have to do that thing to find the charge?
No, I do not. Why? Why? She said, why do I not need to find the charge for B and C? Paige.
Because it's metal?
No, because we would have to find the charge for type 2 cations.
Oh, okay, I see what you're saying.
So why don't I have to find the charge for aluminum or magnesium? Why don't I have to find it? Cole?
Nope.
With cycling.
Yes. Aluminum and magnesium, as well as cesium, are all type 1 metals. Okay? Ready to move on? Yes, Keaton?
What if it's not a metal?
That's the type 3 binary compounds that the video horribly overlapped, that I will have uploaded by 10 this evening. Good question. Pardon? Yeah. All right. Name the following compounds. Go. Go.
Rubidium oxide.
Nice. Questions? Go. Yeah, do you see why I had to give you those symbols? Mm-hmm. And
Strontium iodide.
close, strontium.
Strontium?
Mm-hmm.
Now what does that one change?
What?
What is that one?
It doesn't.
Oh, makes you pronounce it wrong. I get it. I've been pronouncing it wrong.
It happens.
So it's strontium?
That's why it's the same.
Yes, ma'am.
So when there's the, like, the medium with the 2, would it ever matter where the O2 is? It's always a second.
It does matter where that 2 is.
Okay, so like if, I guess you're asking why is, yeah.
Why is there a 2 here and the 2's here?
Not so much that is, but if that's the one that's got the 2, why isn't that one that's got the I or the 8 or anything on it instead of the second one?
Oh,
The
shoot.
second
The
one.
ending.
The ending. Okay, the ending for the polyatomics, just O by itself, like that, will always be I'd. It would, a polyatomic ion has a charge, and I will have to hook those polyatomics up with a cation. Does that make sense? And then you won't see the charge. Does that help? Okay, don't worry about the polyatomics just yet. Right now, there will be no polyatomics coming at you. Does that help? Good. Any other questions? 3 points. Any other questions? Yes, Cole?
Why don't we say like strontium iodide?
You never, ever, ever, never, ever, ever, never use prefixes in naming ionic compounds.
Oh,
And the reason we don't,
Because we know this charge on this compound has to add up to
Like
0. It has to add up to 0. Absolutely. There's no need to tell me how many iodides are in it because I'm a chemistrian human. I know the charge on strontium. Therefore, I know how many iodides I would need to put into the compound if I were to reverse the process. I don't need to be told how many iodides. The framework says I am going to need 2 because strontium has a charge of 2. So an iodide has a charge of -1. So I automatically know I need 2. So there's no need to tell me how many there are. Capiche? All right.
good question, 3 points. Go. Sammy. Nice. Questions? All right, got it back. I'm in charge, not you. All right, draw my little line thingies, okay? Now, we know that this compound has to equal what charge, everyone? 0. all ionic compounds equal 0. Okay, oxygen has what charge on one oxygen anion? Taylor? -2. And everyone, -2 times 2 is? -4. So what number does tin, this side of the ionic compound, have to be? This side of the compound has to be, yes? +4. So how many tins do I have? 1. So what's 1 times 4?
4.
So tin has a charge of, ladies and gentlemen, so the name is tin 4 oxide.
Because if you did it my way, like,
Yeah, it's the same thing.
yeah.
Yeah.
You would just,
Yeah, you're fine. Yes, ma'am.
When you write like 4 in Roman numerals, is it better to do it that way or 4 like
No, it's better to do it this way. The V means
5?
5, and look, it says 1 before 5. Yeah, yeah, 1 before 5. 1 before 5 would be? Yay, us. I don't know.
I don't know.
All right, next, go. Yes, ma'am. Question. The only, because you have to memorize type 1s, everybody else is type 2. For the metals, which make up most of the periodic table, right, except for that tiny little group over here. So, column 1, column 2 are type 1s. You know their charges. Aluminum, gallium, indium, always +3. Zinc and silver. Zinc's 2, silver's 1. Everybody else is type 2. 3 points, good question. Yes? Oh, for the next one? Okay. Who else has the answer for the next one? You have a question. I'm listening.
Can you subtract the 2 to get the -4?
No, I multiplied these. -2 times 2 is -4. 3 points. Next. All right, give me this next one, please. Give me the next answer, please. Sammy? Yes. Oops, I don't want to write it there. Try green. Is it Ian or Owen?
Ian.
Oh, good. Questions, please. Lydia.
Sulfur is 2 negative, why isn't it 4?
Okay. Has to equal 0, correct? What's the charge on sulfur, you said? -2 times 1 is? So this side of the compound has to be? And how many do I have? No, how many tungstens? What? How many tungstens are here in this molecule? 1. So +2 times 1 is? Answer your question? Okay. Any other questions? All right. Who's got the next one? Austin.
Would it be manganese or chloride?
Yes, it would. Got a little carried away there. Questions? Does anybody want me to diagram this one? Like I did the last two. I'll diagram it if you want me to. You do? Very good. Point for asking. Where's, oh, there I am. All right, it's got to be a little diagram though, okay. What's the charge on chlorine, please? -1. -1 times 4 is? So this side of the compound has to be +4. How many manganese do I have? 4 times 1 is? Good. 3 points. Yes. Thank you. D, go. Don't be packing up. Yeah, unfortunately. Grace, do you have this one? Try it. Be brave. No, ma'am. Yes, sir. Good. Now freeze, stop, and look up here. Do not be packing up because it'll really irritate me. Okay. We know this molecule has to add to 0. What is the charge on oxygen? Yes, Ann? Yes. I'm going to write -2. -2 times 3, everyone. So this half of the molecule has to be +6. 6, what number, times 2 will make 6? +3. 3 times 2 is 6. So that's why it's chromium 3 oxide.
So you take always take the number from the rules that's the one you're figuring out.
Yes. 3 points. What I will do tonight is I am going to post this video onto Echo, or this PowerPoint, onto Echo for you. So if you want to go back and review the lecture notes and how I got those at any time, it is there for your reference. You have one video for the weekend, type 3. Have a fantabulous weekend.